Have you ever pondered on the mechanisms behind how predictions are made in machine learning? One of the fundamental techniques employed is linear regression. It's a concept that might sound complex at first, but once broken down, it becomes surprisingly simple and fascinating. Imagine a scenario where you're trying to predict the price of a house based on its size. Linear regression helps in creating a relationship between these two variables: the size of the house, known as the independent variable, and the price of the house, the dependent variable. This relationship is often visualized as a straight line, hence the term linear in linear regression. Now, you might ask, how is this line generated? The answer lies in the equation of a straight line, which is y equals mx plus c. Here, y is the dependent variable, x is the independent variable, m is the slope of the line, and c is the y-intercept. In the case of our house example, u would be the price of the house, x would be the size, m would represent the change in price per unit increase in size, and c would be the base price. However, the real world is seldom as straightforward as a simple line. This is where the concept of error comes into play. An error is the difference between the actual value and the predicted value. Linear regression aims to minimize this error, thereby making the predictions as accurate as possible. The method used to minimize this error is known as gradient descent. It's like a person trying to find the lowest point in a valley by taking steps in the direction of the steepest descent. In the context of linear regression, the valley is the error, and the steps are adjustments made to the slope and y-intercept to minimize this error. Now let's summarize. Linear regression is a fundamental predictive technique in machine learning that establishes a relationship between two variables, visualized as a straight line. The line is determined by an equation, and the accuracy of the predictions is increased by minimizing the error, using a method known as gradient descent. So the next time you're marveling at the accuracy of a machine learning prediction, remember, it might just be the magic of linear regression at work.